There's a device I've been seeking since I started this channel, a smart curtain rod. Now, I have smart roller shades, both DIY and manufactured, but that's not what I really want upstairs. What I want upstairs is something that I can use with the existing curtains and Home Assistant to open and close them. If you've been with the channel for a long time, you may remember this. This is the track I printed and installed for my geared curtain system. That system did not go quite as well as I had hoped. I ran into many blockers along the way to end up with this configuration. That's right, these curtains have remained like this since the last video I shot about them. That was in June of 2024. One day I was looking at the curtains and I thought, I'm just going to go ahead and make some simple sliding hooks that can fit into the tracks so the curtains can actually move. So I did that. I made this. This is just a passive sled, more or less. When I fit it in place to test if it would bind or not, I thought I might fit a gear to match just one of the rack gears inside the track and drive the little sled hook thing to move the curtain. I set off to experiment. What better way to experiment than, let's call them TMBL. They might be Lego. I came up with a gear train to reduce the insane RPM of this motor, which almost certainly would have just ripped teeth out somewhere or twisted a shaft or something. It would have been bad, is what I'm trying to say. Unfortunately, on the test fit, the sled hook thing didn't fit. So rather than waiting for another print, since this is just a proof of concept anyway, I just took a few millimeters off the top with the trusty old benchtop bandsaw and proceeded with the test. Not only did that test succeed, it succeeded better than any test that would follow. Now, I know this could be done with much less power consumption using something else, but I happen to have quite a few Raspberry Pi Pico Ws lying about, so I'm using them. I'll also be using one of these tiny motors with their ridiculous gearbox, and a motor controller I have for other reasons. Eventually, I'll probably just replace it with a smaller single channel. For the actual drivetrain, I figure why reinvent the gear, especially since I already printed TMBL gears that are exactly the same size as the original track gears, and the TMBL teeth happen to also be the same as the track gears. Imagine that. So I printed a little adapter for the tiny motor that would allow me to attach a small drive gear. This is the first design to use the drive system I decided on. After a bit of soldering and connecting to terminals, I had a working prototype, sans TMBL. Mostly. I decided to remove one of the curtains and its original carriages altogether to give the prototype some running room, mostly to see if I could pull a curtain closed. This first design had a few shortcomings, as is to be expected, and it gave me a little trouble. However, it was good enough to encourage me to press on. So, press on I did, after 2.5 hours of printing. Everything seemed to be in pretty good working order, and I thought it was all going amazingly smooth when an all too familiar problem cropped up. I forgot to leave clearance for the joint sleeves. So, back to the printer. After another 2.5 hours, I was ready to test the next iteration, and to my amazement, it was all very smooth. That is, it was all very smooth until I added the other hook sleds. Now, I actually thought about this, but not until after I had printed all of these stupid things. The pointy wedge shapes make them jam together to form a sort of break inside the track. Not really optimal. So, you guessed it, back to the printer. To save time, I thought I'd just knock the battery and controller mounts off so I could prove the blunt shape worked without having to print quite so much. However, I did a very stupid thing. Perhaps you can tell what that stupid thing is. If you follow me on Blue Sky or Instagram, you already know. That's right, the pinion gear shaft hole is just not there. All is not lost, though. This little thing printed in half the time, so I decided it would be the new passive sled design. We've all had hopes and dreams at some point. Since I was redesigning it and it was already late, I decided to put the battery holder and controller mount back on because I didn't have to worry about the time. That, however, was dumb. Why? Well, because it distracted me from doing the very simple thing I set out to fix, and so this version also did not have the pinion gear shaft hole. Back to the printer. By this time, I was out of gray filament, in case you hadn't noticed that this is, in fact, not gray. I learned something new by using the only thing I had left that wasn't a bright, vibrant color. I learned that clear filament is for some reason a little tougher than the rest of my filament. Taking the supports off after this print was violent, and there was much snapping and shrapnel. My CNC room is full of both debris and debris. It was so violent. This version appeared to be pretty smooth, but again, this wouldn't be worth doing if it didn't defeat me at every possible turn, thus strengthening my morale by beating it all out of me so I needn't worry about it in the first place. This time, it was that there really does need to be a slight taper in this direction as well as against the tracks. It just can't come to a point. Back to the printer. The next version showed improvement, but there was too much slack at the top, so it wheelied and jammed from time to time. The version following that kept getting stuck and scraping the drive gear off, something I shouldn't have blamed on the sled because this could have been the working version, but it wasn't. The next one, the battery case, had been extended and it caught. Then I had to alter the angle of the edges. Finally, I got all the clearances and mounts working harmoniously, and the drive gear kept popping off like before. I tried one more time in case it was a fluke, and it was not. It was time to unleash the Suplu. After many days, many tests, many prints, and many nerves, I finally have a working self-motivated curtain hook sled thing. As I'm writing this script, the other passive sleds I need are printing. When they're done, I'll take more video of it and share it at the end. I'm also short one motor controller because I'm not made of money. If I was, I wouldn't physically be able to host a YouTube channel you've all definitely subscribed to and are presently remembering to like the video so the Algo Dragon brings me good fortune. Or moderately okay fortune. More like minor rebate fortune, really. Anyway, I feel good that I was finally able to create a working drive system. Unless it jams after it's all printed, in which case I feel good that I'm only one or two more iterations from this milestone. In the next video, I'm going to learn the thing how to tell where it is. That's going to require doing something clever, or possibly whatever it is that I'm going to do. Anyhow, that video won't take nearly as long to appear as this one did, I'm pretty sure. I've got a few other interesting things that I'd like to share in the next videos as well. I hope you enjoyed this video, and I hope you'll join me next time as I continue to explore and build smarter circuits.